So yeah, I'm here today to present Sigstor. My name's Luke Hinds. I work in the office of the CTO at Red Hat, where I lead a team that are focused on security. Okay, I've been working predominantly in supply chain and cloud native security for the past year or so. So Sigstor. So everybody knows at the moment there's a lot of chatter about software supply chains and their lack of security. We've been working in this domain for, like I say, almost a year, but things have really come to a head now. And so, especially with this executive order, so everybody's running around trying to find S-bombs and trying to find what various solutions there are. And Sigstor is focused on solving part of this problem, okay, because it's a large problem space. There's many heads to this beast. So we're tackling one around software signing, which I'll go into shortly. So I'm not going to walk through all the various attacks because we only have so much time here. But we did a sort of an audit, an investigation to look at who is signing code today. Okay, and it's a very dotted picture. There is a lot of folks have a trust on first use model. Others have keys that are stored on websites or GitHub repos, readmes, sorry. And one that we've actually changed recently is Kubernetes. So we recently onboarded them. But most of these projects we're actually talking to, and we're looking to introduce them to using our signing system, which I'll go into shortly. But it's the same thing with package managers. Some of them have systems, but users don't use them at all. Others have very good adherence, okay? Others have nothing at all. So for example, you'll see there's crates.io. So one of the great things about Rust is you obviously get very good safety guarantees around the compilers, enforcement of ownership and so forth. But everything that you pull down is not signed. So you're running unsigned code at system level. So you know, these are same with Ruby. They have a form of signing, but nobody's actually signing much. About 2% of people are signing things at the moment. So it's a very spotted picture, and it's not a particularly great picture as well. So just a kind of a very, you're a security centric group of people. So I imagine this is probably common knowledge to you, but what does signing provide? So we can verify the integrity of content. So that any particular content is tampered with or changed to one bit, then that sort of throws out the integrity. Non-repudiation, so I know that whoever signs something is in possession of a private key, okay? Authentication, if a private key is conceptually bound to some sort of identity using, for example, PKI, then you can assume the identity of that particular signee. And if there's some timestamps, then you have guarantees around when that signing event occurred. Now, the problem is that for a lot of people, managing private keys is a challenge. It's expensive. You know, if you consider you have somebody like somebody that's running maintains a Node.js project, okay, in their spare time, and they can't afford to buy a YubiKey, and they don't want to. They don't want to go through the trouble of setting that up. But at the same time, that dependency is pulled into a ton of enterprise software and so forth. So this is the situation that we have. The UX leaves a lot to be desired. PGP is great. I've used it for years, but since COVID's come along, actually meeting up with people in person to form sort of a Web of Trust signing type event is difficult. Revocation's difficult, and you know, the existing mappings of identity to key pairs have their shortcomings as well. So if we look at the people that do implement it, it's a very it's a picture that could certainly do with improving. Okay, and so we came up with Sigstor. Okay, and Sigstor is it's a project under the Linux Foundation. And it's a collection of projects that can be deployed independently or together, provide the infrastructure to provide software signing and transparency. So under the Linux Foundation, we're looking to launch this as a public good service. So plans are underfoot at the moment to do that. And we very much basing this on the Let's Encrypt model. Okay, but as I say, all of this stuff could be run behind a firewall. So you could stand all of our infrastructure up within your own sort of corporate network and use it to sign artifacts and so forth. So kind of a quick decoder of the projects. We have Fulcio. This is our CA, our web PKI, and this provides code signing certificates. They're based on an Open Identity Connect grant. We have Record. This is a signature transparency log. So this gives us an append only immutable store of sign-in materials. And then we have one of our particular tools is very popular. It's Cosign, which is a container signing tool. And we have many other tools that are under development and starting to reach various levels of maturity soon. So Maven, plugin, Ruby gems, doing some really exciting integration within Toto, Tough, SPIFFE, Inspire, and looking to stand up some public log monitors and so forth. So transparency logs, I'm going to whiz through this quickly, but if anybody's not familiar with them, they're basically built on a technology called a Merkle tree. So it's these leaves of hashes are concatenated together until you arrive at an eventual root hash, and that root hash represents the integrity state of the entire tree. Okay, so you can then do these. You can compute these things called inclusion proofs. So I can check that a particular data set that I have that is in the tree, its integrity is sound. Nobody has tried to tamper with that, because if anybody tries to tamper with this, it's like a hash extend function. It breaks the computational structure of the entire tree. Okay, and the good thing about these transparency logs, they're openly auditable. So we run our transparency log in the public, so other people can monitor it and make sure that there's nothing untoward happening with the transparency log. So this is our quite sort of complex architecture. Okay, so I'm not going to try and walk through this now. What I'm going to do is going to do a very, very quick overview of how this plays out. So we have our user, a developer. They got some sort of artifact they want to sign, a container, a blob, an SBOM, a tarball, whatever they may be. We have our web PKI. So this is the Fulcio project. And we have two transparency logs, a certificate transparency log and a signature transparency log. And what occurs is the developer generates a key pair. So these are ephemeral. These don't even touch the disk. We encode these to memory because the idea is that these are going to be short-lived. Now the user will, using the public key, they will, using their key pair, they will send a challenge effectively to our web PKI. Okay, and then our web PKI will respond back with an open identity grant session screen. Okay, so that they can click on, they have an account with GitHub or Google or Twitter or whoever, they can select that, and then what will happen is if that passes, sorry, I've got OK Google going off in the background. If that passes, what will happen is an X509 certificate will be sent to our certificate transparency log. This will contain the email and that we got from the IDP, not the one from the user. Okay, the challenge is simply to fix the identity of the user to the public key pair. Okay, and this is time stamped as well. Now, after that's happened, a certificate is returned back to them that they can then use to sign with. So they go ahead and sign, okay? And then a signature is generated, and the public key and the digest are then stored in the signature transparency log. So we have these two disparate logs now. So this is sort of the magic part, which is that we can then throw away the keys, okay? We don't have to worry about storing those securely and worry about revoking them. They're gone. Because what we now have is a trust root. So using the two transparency logs and the key pair that's associated between them and some time stamping, we then know that an individual in charge of an identity provider account signed a particular digest at a particular time. Okay, so we then have guarantees that whoever is in charge of this account, okay, so my own account, had a public key pair, they signed something and they generated a signature. And we have this trust root that's set in these immutable transparency logs. And this then gives us guarantees that this identity signed this. Now, accounts can be compromised, of course, but the nice thing then is we have it in the transparency log, because if it's not in the transparency log, you don't trust it effectively. So this allows us to then monitor the log for particular entries being made, so that you can you can watch the watcher, so to say. Okay, and this uses the same technology as certificate transparency. They do this for domains. So, for example, Facebook.com will monitor the certificate transparency log to look for people signing CSRs with their domain. Okay, so then they know that somebody has signed something that doesn't belong to them and is in fact their own domain. Okay. So whizzing on, because we've got a few seconds left. We're a very active community, 40 contributors. It's a very fast-moving project. We're under soft launch at the moment, so we have our public-facing Recor and Fulcio instances. We plan to go live with this at the end of 21. There is we're 100% open source. Everything is there to go and read. All of the development is happening in the open. We plan to run a free non-profit public good service, and there's various different companies that are contributing here, as well as NYU, who should be on there, and Purdue University. And that brings me to the end. So right on the dollar there. And I'll stop my presentation. Okay.